All right, so with solving this section 7.6 talks about proportions. That's kind of the key thing, is when you set up these proportions, they're saying that these two sides are equal. You're going to have fractions on both sides. And the easiest way to solve these, remember in the last section we were looking at our denominators and we're trying to come up with the lowest common denominator in order to eliminate these denominators. But a much easier way to do them is you just use what's called cross multiplication. So you're going to cross multiply both sides. So in other words, you're going to do 11 multiplied by x. And then on the other side, you're going to do 9 multiplied by 7. And when you do that, you're going to get 11x equals 63. And now it becomes a one-step algebra equation. We want to eliminate that 11 to get the x by itself. So we're just going to divide 11 to both sides. And we're going to get 63 over 11. Now before you go ahead and enter that answer, you want to just make sure these are reduced. You can enter it like that, but you just got to make sure they're reduced. There's not a number that will divide into both 63 and 11. We know 11 is a prime, so unless this top number is a multiple of 11, we're done. So you would just enter that as that fraction as it is, 63 over 11. No need to change that into a mixed number. That would be the answer that you would enter. All right, so our next example is similar to that first one. But what you'll notice, instead of just a singular x, we have 2x plus 1. And again, when we're doing these, it's a good habit to put these in parentheses, because when we do, we want to cross multiply these proportions. And that would remind us that the 3 has to be distributed to not only the 2x, it also needs to be multiplied to the 1 as well. And then we're doing 2 times 12. This step will go ahead and just distribute the 3 into both numbers, and we'll get 6x plus 3. And then 2 times 12 would give us 24. It's a two-step algebra equation. The first step is to remove the plus 3 from both sides. We're going to get 6x equals 21. And then divide 6 to both sides, and we're going to get x equals 21 over 6. Now I think I made the mistake of entering that as it is without really checking if I can reduce that. And that has to be reduced because 3 actually goes into each of those numbers, which would give us 7 over 2, which would be the reduced form of 21 over 6. So if you enter that, it's going to tell you it's wrong. So if you think you did pretty good job checking your work, if it's not taking the answer, make sure that answer is simplified before you go on. All right, so example 3, difference between example 3 and example 2. I think example 2 only had one binomial in its fraction, and this one you'll see that there's 2. So again, just put parentheses around them so you'll know when I cross multiply that those numbers need to be multiplied to both terms inside the parentheses. So we're going to do 5 times x plus 2, and then we're going to do 3 times 2x plus 5. And then again, to solve these, we have to distribute both sides to both numbers. This would give me 5x plus 10. And over here, I'll get 6x plus 15. Got variables on both sides, and we got constants on both sides. So we want all the variables on one side, all the constants on the other. What I'd probably do in this case is just move the 6x, eliminate the 6x first. That's going to give me negative 1x plus 10 equals 15, because those 6x's now cancel out. Eliminate the plus 10 by subtracting 10 to both sides. So again, remember, and just be careful here, don't put that as a 1, that's a negative 1. You're moving the negative 1x down. 15 minus 10 would give me 5. And then my last step is just to divide negative 1. But again, you had a choice to make. You could have subtracted the 5x and kept the positive x here and get rid of the 15. Either way, you solve this as long as you come up with x equals negative 5 as our answer. Then we did it correctly. I'm going to do another problem similar to example 3, just so you can see that again. We'll get x plus 2 over 3x plus 8 equals 2 over 5. So again, it's the same kind of concept. We're going to put these in parentheses. We're going to cross multiply. So we're going to get 2 times 3x plus 8 equals 5 times x plus 2. We're going to distribute the 2 into both numbers, 6x plus 16. And we're going to do the same thing on this side, 5x plus 10. And again, we're going to kind of speed this up a little bit. I'm going to show you how I can kind of do 2 steps at once. Move all the variables on one side. I'm going to get rid of the 5x. And while I'm doing that, I'm going to move this constant over here as well. So I'm going to get rid of that 16 while I'm doing that. So on this side, I'm going to be left with just x, or 1x. The 16's gone. This 5x is gone, right? And I'm going to get a negative 6 on that side. Now, if you want to do this one step at a time, that's fine. I showed you on this side how we do it one step at a time. This is just doing these 2 steps in one step. As you get better with your algebra, you'll be able to do that. So again, the answer is x equals negative 6 for example 4. On this section, I did 8 examples, so we got 4 more to get through. Alright, so example 5 is our first word problem. The one thing about this section and this homework assignment and even the test, this is really the only type of word problem they give you. It's dealing with this cereal X, and they're telling you there's 110 calories per 177.4 grams of cereal X. Find how many calories are in 215 grams of this cereal. So what you're going to do is you're going to set up a proportion. And there's one thing that's extremely important when you set these proportions up, that you have your numerators and denominators the same on both sides of your proportion. So in other words, let's start with the information we're giving. They're telling us there's 110 calories per 174 grams. So when you set this up, you were going to put your 110 calories on top, and then in 177.4 grams on the bottom. And once I do that now, I've already established whatever I have over here has to deal with calories on the top, and whatever I have on my denominator must deal with grams. So once I've set that as kind of a rule, I can't have calories on top here and grams on top here. If I put calories on top on this side of the proportion, I have to have calories on top on the other side. Same thing with the grams. I put the grams on the bottom, grams have to remain on the bottom. So let's go to that second sentence now. It says, how many calories? So again, what I need to find out is how many calories. So again, I don't know how many calories. That is what I'm trying to find out. That is my missing information. So then that's where we use a variable, because I don't know how many calories. That's what I need to solve. I don't know how many calories, but I know there are 200. So again, how many calories are in 211.5 grams? So it's giving me the grams. It wants to know how many calories. So this is kind of, again, how you set up the proportion. Most of your proportions, you're going to have that one unknown variable that you'll have to solve. Again, once you set it up, now to solve it, we're just going to cross multiply. So we're going to have 177.4x, and then we have to do 110 times 211.5. That's when you want to use your calculator. And I'm going to get 23,265. Once I do that, now you'll notice this is a single-step algebra equation. So now all I got to do is divide that 177.4 to both sides. And what you end up getting is 131.14. Now, one thing you got to be real careful with these problems, it tells you to round this answer to the nearest whole number. So the nearest whole number is right there. So you're looking to see, as long as that's not 5 or greater. So our answer then would be 131 calories. So again, don't enter that 131.14. It'll tell you it's wrong. You have to round it. It says round it to the nearest calorie. The whole calorie. So 131 calories. So you'll have a few examples with this serial X, so you may just have to change a few of the numbers, but you're going to solve these all the same way. The key is setting up the proportion properly. And again, calorie, if you go, you can go grams over calories, that's fine, but you better have grams over calories on the other side. So just when you set up these proportions, and we're going to get into some triangles as well, it's just making sure these things, these tops and bottoms all match, they correspond, okay? Alright, so we start dealing with these similar triangles. So then once they tell you these triangles are similar, then the corresponding sides relate to the same corresponding side. So in other words, you can set up a proportion on these triangles, but again, you have to set them up the same way. So if I go 3/10 on this side, then I got to do the same thing on the other side. In other words, I got to write y/6. So that's one way I can set it up. I also could go this side to this side. In other words, I can go 3/y and have the same as 10/6. And so you have some options on how you want to set these up. It's just got to make sure that, again, if I go this side to this base, okay, you see I'm doing this side to this base. I have to do the same thing on the other side, this side to this base. I can't go this side to this base and then do this to this. Okay, so in other words, I can't flip these around. Now, that's an incorrect proportion. So I got to go corresponding side, whatever I use to set up the one side, I have to use the same kind of thing on the other side. And I'll show you, even though I have two different examples set up, that I'll get my same answer both times. So cross multiply, you can get 10y equals 18. And then I just got to divide 10 to both sides. So I'm going to get y equals 18/10. You'll notice even over an even. I think you guys have heard me say that 100 times now, that I have to very least divide 2 to both of those, and I'm going to end up getting 9/5. You can do the same thing on this side. I'm going to get 10y equals 18, so you'll see it's already going to give me the same answer. Divide by 10, divide by 10. Y equals 18/10, which we already said reduces to 9/5. So our answer we would enter for this, you just could enter it just like that as a fraction, 9 being divided by 5. All right. So we're going to do a couple of these. The biggest difference between this one and the previous one is you'll notice I got all three sides of the triangle. On here I have two of the three. There's my missing sign. So I'm going to want to solve for y. And again, it tells me find the unknown length of y in the following pair of similar triangles. So these are similar triangles. That's important. So I can set up proportions to solve for that missing side. So when I set up these proportions, a lot of different options I can do. But I want to make sure they include this side. So what's the corresponding side of this y on this other triangle would be this 15. So if I go 13 to 15, that's fine, because then it'd be 6.5 to y. Or I can go 7 to 15, and the corresponding would be 3.5 to y. So you have options on how you want to set this up, but again, you want to include that y. So we can try it both ways. Let's go 13 over 15 on this first triangle. So I'm going this side to this hypotenuse side, or 13 over to the 15. So what is the corresponding on this other triangle? Again, if I'm using that, I have to use then 6.5 on the top. And if I use that 15, then I want to use the y over here. So there's my proportion. I can cross multiply. I'm going to get 13y equals, let's do 15 times 6.5, and we get 97.5. We're going to divide 13 to both sides. And when I have a decimal, I can just go ahead and use my calculator, and I end up getting 7.5. So now we're going to show you that, again, you can use different proportions. And I used 13 to 15 and 6.5 to y. We can also say, if we wanted to use 7 to 15, that'd be fine too. So I'm going to have 7 to 15. So what would be the corresponding? I have to use the same thing, right? So 3.5 would be on the top, y on my bottom, cross multiply. 7y equals 3.5 times 15, ends up giving me 52.5. Then I'm dividing 7 to both sides, and again I get 7.5. So the point of these, though, is I'm just showing you that there's different ways to solve these to get to that 7.5. And so that's really your choice. As long as you're set up these proportions correctly, then you should get back to that same answer. Let's do one more example, and it's going to basically do that same triangle there. Same type of example, these just different numbers. So we have 13, 9, and 17, 2.25, 3.25, and y. One second, I want to go, before we go on to that, I want to go back to this a second. Not sure how many of you noticed this, but if you look, each of these sides was actually half of whatever its corresponding side was. So in other words, half of 7 is 3.5, right? Half of 13 is 6.5. So if we were going to take half of 15, that would give us 7.5. So if you recognize that, then you can find your answer maybe a little bit easier. But if you look at the reason why I mentioned that is if you look at this one, it's not as clear. So how does 9 become 2.5? How does 13 become 3.25? It's a little more complex, right? So again, we have options on how we're going to set up our proportion. I'm just going to go 9 over 17 and set that equal to 2.25 divided by y. Okay, so again, this side to this side, this side to this side. Staying true to our proportions, we're going to cross multiply 9 over y gives me, and I do 17 times 2.25. Try that again, 17 times 2.25. There we go. And I get 38.25, so all I got to do now is divide that 9 to both sides, and I get 4.25. So there you go, that's 7.25.